The first thing we need to do is writing the determinant of this system. We will do that by collecting coefficient in front of x, y, and z. The first row are 1, 1, 3. The second row are 1, 3, k squared. And the last row are 3, 1, 3. Now we can say that with three number zeros on the right hand side of the system, we can conclude that this system is homogeneous. This point is very important. Why? Because as a homogeneous system has a non-zero solution, then the determinant must be equal to 0. From this equation, we can find the value of k, and with k, we can come back to solve this system. So the next thing we need to do is calculate this determinant. Let me erase some. To calculate this determinant, we can choose any rows, any columns. Here we'll choose the first column, random. The first item in the column is the number 1. Multiply the second order determinant, 3k squared, 1, 3. The second item in the column is number 1. We need to add a minus sign here. Multiply the second order determinant, 1, 3, 1, 3. And the last item in the column is number 3. Multiply the second order determinant is 1, 3, 3k squared. I am sure that you can remember very well how to calculate these determinants by applying alpha rule with minus sign. We get here 1 multiply number 3 times number 3 is number 9 minus 1 times k squared. This determinant equal to 0. Why? Do you see? The first row and the second row are similar item by item. So we ignore that and do next. Plus number 3 multiply. Here we get k squared minus 9 equal 2 square minus 18 equal to 0. K squared equal 9. Number 9. It is very beautiful. Do you see that? With k equal to, k squared equal to number 9, we come back to solve the system. I will copy, put it here. Let me crop it. It is very simple. We only need to replace k squared by number 9. Let me zoom it. For convenience, we put a number next to these equations 1, 2, 3. To solve this system, we will apply subtracting and adding method. We can subtract equation number 1 from equation number 3, and we get here 2s equal to 0 or x equal to 0. And from this equation 1 becomes y plus 3z equals 0 or y over z equal minus 3. With these values, we can come back to find the final result. Here, x plus y over z equal 0 minus 3 equal minus 3. This is the last result, the final result. How do you feel? Is the problem difficult? The most important point I would like to remind that here we apply a property of homogeneous system. That is, if the system has a non-zero solution, then determinant of that system must be equal to 0.